In your earlier mathematical studies, you became highly familiar with polynomial functions like x squared or x cubed, where the base varies and the power is a constant. This unit flips that relationship entirely on its head. We are going to explore exponential functions, where the base is a constant and the variable itself becomes the exponent. These functions are the mathematical engine behind modeling real-world phenomena that compound continuously, from runaway population growth to radioactive decay. To reverse this process and solve for unknown exponents, we need logarithms. By mastering the natural logarithm, you will unlock the ability to dismantle and solve complex nonlinear equations. This is an absolutely essential bridge to your A2 calculus studies.
We begin with the mathematical engine of continuous change, the exponential function. You will learn how the fundamental constant e naturally models continuous growth. But what happens when you need to mathematically reverse an exponential operation to access an unknown exponent? That is exactly where the natural logarithm comes in. You will define ln x as the exact inverse of e to the power of x, and learn why logarithms are strictly defined only for positive numbers. You cannot evaluate the logarithm of 0 or a negative number. To manipulate these functions algebraically, you will need to memorize the 3 laws of logarithms. These laws are your algebraic toolkit for compressing sprawling expressions into a single neat term, or expanding them to isolate specific variables. Examiners will expect you to document every single application of the product, quotient, and power laws in show that questions. You simply cannot differentiate or integrate later in the course without total algebraic fluency here. Once you know the laws, you will use them to solve equations where the unknown variable is trapped inside an exponent or locked within a logarithm. A major Cambridge examiner favorite in this topic is the hidden quadratic. You will be expected to spot how an equation containing e to the 2x and e to the x is actually a standard quadratic equation in disguise. Remember, the command word solve in paper 3 almost always demands an exact value, like a half ln 3. Prematurely converting your answer to a decimal approximation will lose you the final accuracy mark. Finally, you will sketch the graphs of these exponential and logarithmic functions. Because they are inverses, the exponential curve and the logarithmic curve are exact reflections of each other across the line y equals x. You will learn to track their intercepts and, crucially, their asymptotes under different geometric transformations. An A-star candidate always draws asymptotes as dashed lines and explicitly labels their equations. Failing to clearly show that a curve approaches but never touches an asymptote will cost you valuable marks.
By the end of this unit, you will deeply understand the inverse relationship between exponential and logarithmic functions. You will be able to apply the laws of logarithms to solve complex equations, spot hidden quadratics, and precisely sketch and transform their graphs. Let's get started.